An object from another star system, designated 3I Atlas, has just defied expectations again. On November 6th, telescopes across the globe captured something that shouldn't be possible. According to new reports, 3I Atlas briefly surged in brightness by a factor of 5, changed colour, and then did something no comet ever recorded has done. It moved, deliberately, against gravity, and without a tail. This isn't speculation. This is being confirmed by astrophysicists, amateur astronomers, and international observatories. And the implications? Staggering. Because this may not be a comet at all, it might be something else. Tonight we bring you inside the timeline of a mystery still unfolding. With new Chinese optical arrays and Italian telescopes updating live imagery, and NASA staying unusually quiet, we're left with one question. Is this natural, or are we being visited? Welcome to this special investigation. If you're watching this, you're early to a story that could rewrite our understanding of spaceflight and life beyond Earth. Don't forget to like this video and tell us in the comments where you're tuning in from. We're tracking observations worldwide. Because on December 19th, just days before Christmas, 3I Atlas will pass closer to Earth than any other known interstellar object. And what it does next might change everything. In early September 2025, astronomers in China using the Xinglong Observatory's 2.16-metre telescope spotted something strange in the inner solar system. At first glance, it looked like a comet, fuzzy, dim, moving fast. But within days, other observatories joined in. The Las Cumbres Observatory in Chile, the European Space Agency's Solar Orbiter, and the NASA-funded Haleakala Station in Hawaii. They all noticed something odd. The object's orbital trajectory didn't match known comet families. It wasn't bound to the sun, it was diving in, fast, then swinging out again. It was interstellar, like Oumuamua in 2017 or Borisov in 2019. But this one, 3I Atlas, had its own script. The object approached the sun as expected, reaching perihelion on October 29, 2025, at just 203 million kilometres, roughly halfway between Mars and Earth. But instead of shedding icy material or forming a visible cometary tail, it remained visually compact. No tail, no dust halo. Instead, jets. 7 distinct plumes were detected via spectral imaging from the Virtual Telescope project in Italy, led by Dr. Gianluca Massi. These jets emitted radiation in narrow bands, rich in nickel, and surprisingly low in iron, unlike typical comets which show high water and carbon signatures. Most shocking of all, these jets didn't behave randomly. They seemed to pulse, synchronized, directional. Some astronomers, including Harvard's Dr. Avi Loeb, proposed that this may suggest internal propulsion, not gas venting from heat, but thrust. And on November 7th, in an interview with Newsmax, Dr. Loeb said, it maneuvered. That statement lit up social media and triggered calls for NASA and ESA to release high-resolution imaging from the Mars Reconnaissance Orbiter and the Solar and Heliospheric Observatory, SOHO, both of which had viewing angles during the perihelion window. Neither agency has released new images as of this recording. But while the official silence continues, civilian telescopes keep watching, and what they're seeing gets weirder. To understand the mystery unfolding, let's look at 3I Atlas's current position and its upcoming trajectory, using Stellarium, the real-time star visualization software. As of November 12th, the object is passing through the constellation Virgo, roughly near the ecliptic plane. If you were to stand in southern Europe or parts of western China just after midnight and aim a telescope low to the eastern horizon, you'd find it arcing slowly toward Leo, with a high-speed outbound curve that's unusually planar. This is key, because unlike most comets that arrive at random angles, 3I Atlas is gliding almost flat along the same orbital plane as the planets, as if it were navigating, not falling. By December 19th, it will be within visual range of major terrestrial observatories, including Keck Observatory in Hawaii, Jodrell Bank in the UK, and NASA's Deep Space Network antennas in Goldstone, California. The pattern here is uncanny. Its path seems optimized for observational visibility, not unlike a flyby. So what is it aligning to? And why now? Interestingly, when you map its closest approach in Skyview, it passes within a few degrees of the origin point of the WOW signal detected by Ohio State University in 1977. Coincidence? Possibly. But some researchers, including teams within the private Galileo project, are preparing spectral monitoring arrays to catch any possible repeat signals as 3I Atlas closes in. Because if there's a pattern here, if this is coordinated, it may be repeating across decades. And if it does broadcast, we may hear it soon. From November 6th to 9th, the Virtual Telescope Project and several amateur astronomers across Italy, the Czech Republic, and northern Vietnam reported something stunning. 3I Atlas began glowing blue, brighter than before, and bluer than the sun. Let that sink in. Normally, comets that get closer to the sun glow white-yellow due to reflected sunlight and outgas materials like water, carbon monoxide, and cyanogen. Some do shift toward blue in certain filters, but never this vividly, not without high-energy emissions or ionized tails. But 3I Atlas has no visible tail. Instead, its spectrum moved toward shorter wavelengths, even as its temperature, estimated by infrared sensors aboard ESA's Gaia mission, remained cooler than 5,800 Kelvin, the sun's average. So why is it radiating like a hot star? One theory involves metallic reflectivity. The object's surface may be nickel-rich, forming a high albedo crust, but that doesn't explain the increase in intensity nor the shape coherence under thermal load. This isn't just a colour change, it's an energy anomaly. Some theorise active emissions, artificial or naturally ionised, while others suggest focused jets interacting with solar particles in non-random ways. The math, however, doesn't lie. To produce the observed acceleration, measured at nearly 150 km/s, 3 Atlas would need to eject over 5 billion tons of mass, with no debris visible, so either it's breaking known physics, or it's hiding something. Since the November 7th statement by Dr. Loeb, pressure has mounted on US space agencies. Harvard's Galileo project submitted a data transparency request to NASA Jet Propulsion Laboratory, specifically requesting radar and optical imagery from the Mars Reconnaissance Orbiter's HiRISE camera. That camera, which orbits Mars, was in prime viewing position during the object's solar perihelion. So far, no images released. On Capitol Hill, Florida Representative Anna Paulina Luna has publicly supported Loeb's request, urging the House Science Committee to review whether 3I Atlas qualifies as an object of unidentified aerospace interest, a term borrowed from recent UAP hearings. In a press conference outside the Rayburn House Office building, Luna stated, "Transparency is essential when it comes to interstellar visitors. The American people deserve to know what our instruments are seeing." Meanwhile, in Las Vegas, the Galileo project has activated its autonomous sky monitoring system, originally built to track UAPs, to point toward 3I Atlas's trajectory. And across social media, amateur astronomers are organising coordinated imaging nights on December 18th and 19th, when 3I Atlas will be closest to Earth. Because if something emerges from it, we'll all want to see. Naturally, scientists remain divided. Some, like Dr. Mark McCaughrean from ESA, argue the object is likely natural, albeit unusual. Jets happen, he wrote in a recent blog post. We've seen Comet 67P do strange things too. But even 67P had a tail, and it didn't manoeuvre. Others are now re-examining Oumuamua and the possibility of non-gravitational acceleration from thin film sails, as Loeb proposed in his 2021 paper. Could 3I Atlas be a more intact version? Could it be what Oumuamua never got to be? Or is this just a new type of interstellar rock, something we've never seen before but still natural? Whatever the answer, it's coming soon. Because in just over a month, on December 19th, 3I Atlas will swing past Earth at a distance close enough for radar, LiDAR, and infrared mapping. And if it fragments, changes speed, emits light, or releases anything, we'll know. But the countdown has already begun. And so is the mystery. Open your visualization software. Stellarium, Skylive, or Celestia. Look toward the constellation Leo, where 3I Atlas is headed. Now draw an imaginary line across the solar system, along the ecliptic plane, that thin, flat orbital field where all major planets orbit. Earth, Mars, Jupiter, even the asteroid belt. Guess what? That's a problem. Most interstellar visitors, like Borisov in 2019, arrive at odd inclinations, slicing through the solar system at steep, chaotic angles. After all, space is three-dimensional. But 3I Atlas is flat. In fact, when you trace its entrance vector back into deep space, as astronomers at Beijing Planetarium, Calar Alto Observatory, and the JPL Horizon System did, you notice something eerie. Its origin lies almost perfectly aligned with the galactic plane, as if it were shot straight in, like a dart through a ring. Now maybe that's coincidence. Or maybe, as some now whisper in forums and astrophysics Reddit threads, maybe this is an inserted path, a calculated one. Because here's what else lines up. On October 29th, it passed perihelion. On November 6-9, it brightened, then turned blue. On December 19th, it passes Earth. And if Dr. Avi Loeb's math is correct, it crosses near Mars orbit in March 2026, at exactly the right angle for a potential intercept by the Juno spacecraft. Are these random dates, or preset checkpoints? Because if this is technology, not rock, then someone knew how to fly. Much of the recent buzz surrounding 3I Atlas comes from the Chinese astronomical community, particularly the Xinglong Observatory and the Purple Mountain Observatory in Nanjing. Using their 2.60mm Ritchie-Chrétien reflector, Xinglong captured some of the clearest pre-perihelion spectral data. Their results were quietly shared in late October via internal reports on the China ESA Science Data Archive. But only snippets have reached the West. What we do know is this: the reflectivity index of 3I Atlas was measured at albedo 0.37, significantly higher than any typical comet, but not as high as solar sails like Mylar. The colour index, BV, was unusually negative, confirming a blue shift well above solar baseline, and most notably its emission spectra included ionised nickel lines, suggesting very high-density internal structure. Now, this data was corroborated by amateur astronomers in Vietnam, Taiwan, and South Korea, many of whom posted direct telescope captures on the Skywatcher Asia network. But China's imagery went further, according to whispers within the global academic exchange, particularly those circulating through the International Astronomical Union's Minor Planet Center. Chinese satellite relays detected non-thermal emissions from 3I Atlas shortly after perihelion. Non-thermal, as in not caused by heat, as in perhaps artificial. Beijing has remained silent officially, but multiple scientific figures within the Chinese Academy of Sciences have reportedly called the object highly anomalous in closed-door consortiums, and so far no one has been able to disprove their data, because the math keeps getting worse. Here's where the laws of physics start crying. Comets accelerate due to outgassing. Solar heat boils volatile ices inside, jets push outward, and the body changes speed slightly. It's messy, uneven, chaotic. But 3I Atlas, it accelerated smoothly, not randomly, and not once but repeatedly, according to radial velocity plots generated from Gaia, SOHO, and ESA's Euclid mission, which caught part of its outbound trajectory during calibration drift. According to compiled estimates, the object moved from 120 km/h at perihelion to 150 km/h by November 10th, gaining velocity in the wrong direction, perpendicular to gravitational pull. That's not what rocks do. To generate that kind of delta V, a natural comet would need to lose roughly 5 billion tons of mass in a visible direction with a tail. But again, no tail, no debris trail. Only those 7 jets, acting symmetrically like nozzle bursts. Harvard's Loeb has a name for this: non-gravitational propulsion. He used the same phrase for Oumuamua back in 2018. But 3I Atlas, it's giving even stronger signals. This leads to one conclusion, terrifying if true. It's not falling, it's flying. NASA has acknowledged non-gravitational anomalies in private modelling, according to sources close to the NASA Planetary Defense Coordination Office. But the official public statements? Muted, reserved. They say it's likely cometary and further analysis pending. And yet, the data keeps updating. And nothing fits. This isn't the first time something like this has happened. Back in 2017, a cigar-shaped object called Oumuamua passed through the solar system. It too came from interstellar space. It too accelerated without a tail, and it too sparked fierce debate about artificial origin. Loeb argued at the time that Oumuamua might be a light sail pushed by solar radiation pressure. Critics scoffed. But now, some of those same critics are quiet. Because 3i Atlas is doing it again, but with more mass, visible jets and a flight path that suggests targeting. Then there's Borisov, which passed through in 2019. Borisov behaved more like a normal comet. It had a tail, it fragmented, it spewed gas. But 3i Atlas, it's silent, cold, controlled, clean. And here's the kicker. Its current position, as seen from Earth in early December 2025, places it within 9 degrees of the origin of the famous WOW signal, picked up in 1977 by the Big Ear radio telescope in Ohio, a powerful, unexplained burst of energy, never repeated. Until now, some scientists are cautious, warning that correlation isn't causation. But for others, including researchers inside SETI, Breakthrough Listen, and Galileo Project, this proximity is too close to ignore. Could 3i Atlas be returning? Could it be retracing a path? Or worse, was it always meant to come back? We are now entering the final phase of this story. As of today, November 12, 2025, 3i Atlas continues to accelerate. The blue glow remains. The jets are active. And amateur astronomers are capturing images nightly. But the big moment is coming. On December 19, 2025, the object will pass Earth, close enough for optical telescopes, radar dishes, and infrared sensors to finally get high-resolution imaging. Every major observatory, from Palomar, Mauna Kea, Jodrell Bank, to Arecibo's digital replacement, will be watching. But the most anticipated reveal? NASA's potential image drop from the Mars Reconnaissance Orbiter, which reportedly had visual on 3i Atlas during perihelion. And if it shows fragmentation, directional shifts, or any unexpected payloads in one, that's game-changing, because then we'll know, definitively, whether this was ice and rock, or engineered. And if engineered, then who sent it? And why? As the story of 3i Atlas continues to unfold, another drama plays out in the background, a silent war over data. It's not just what this object is, it's who gets to define it. And right now the world's most powerful space agencies, NASA, ESA, and China's CNSA, are scrambling behind closed doors. Let's begin with the United States. Despite intense public interest, NASA has yet to publish high-resolution images of 3i Atlas from the HiRISE camera aboard the Mars Reconnaissance Orbiter, which had a perfect vantage point during the object's closest approach to the Sun in late October. Insiders claim those images were flagged for classified review due to unusual vector activity, a term borrowed from aerospace dynamics, not astronomy. Why the secrecy? Some believe the reason is political. Since Dr. Avi Loeb's public statement that the object maneuvered, pressure has grown in Washington. Congressional leaders like Rep. Anna Paulina Luna and Senator Kirsten Gillibrand have quietly asked NASA to declassify orbital tracking data and release raw imagery to the scientific community. So far, nothing. And yet, leaks suggest that what the public hasn't seen might be the most important visual data since Voyager 1's pale blue dot. Meanwhile, in Europe, ESA's solar orbiter and the Gaia mission both captured spectral readings as 3i Atlas departed perihelion. The Euclid infrared mapper, recently activated, also caught partial imaging, but ESA officials have deferred full public release until after December 19th. Why? According to internal sources within the ESA Operations Center in Darmstadt, Germany, the raw frames showed reflective light signatures inconsistent with known mineral compositions. Translated, possibly metallic engineering. While major institutions withhold raw imagery, something troubling is happening online. Public releases are being altered. Multiple images of 3i Atlas, uploaded to ESA's open access media servers, appear different depending on when and where you access them. Initial uploads showed a faint hexagonal pattern around the object, like a rotating prism of gas or energy. Within 24 hours, those same images were replaced with cleaner versions. And no hexagon. A glitch? Or something more? Members of the Astronomy Open Data Collective used metadata tracing tools to compare hashes of both versions. The result? The images were replaced, silently, and without changelogs. What's more, screenshots of a virtual telescope livestream from November 7th briefly showed a pulsing lens flare originating from the centre of 3I Atlas. That flare was later attributed to instrumental bloom, an explanation that left many unconvinced. Dr. Gianluca Massi, founder of the Virtual Telescope Project, admitted in a livestream Q&A, "There are phenomena we don't fully understand, and I've submitted those frames for independent review." Translation: even experts are no longer sure what's real, and that's what worries people the most. Because if the public can't trust the images, what's left? Let's go back to those 7 mysterious jets. Captured by multispectral imaging from Beijing, Prague, and Arizona, these emissions form a rotational pattern, unlike any observed in comets. They aren't just symmetrical, they're timed. Analysis from the SETI Institute suggests that the jets pulse in repeating intervals, bursts occurring every 88.6 seconds, matching a frequency harmonic first flagged by Breakthrough Listen's Green Bank telescope. We're not saying this is communication, but it's not natural chaos either, because when researchers modelled the behaviour of 3I Atlas under expected solar heating, the output pattern looked random, sputtering, uneven, inconsistent. What we're seeing isn't that, it's controlled, rhythmic. Think about jet nozzles used in spacecraft attitude control. They pulse in bursts to rotate or pivot the vehicle. So what if these jets aren't ejecting gas randomly, but steering, a manoeuvring system? Even Loeb's team at the Galileo Project's Las Vegas Observatory suggested that some form of active guidance might be occurring, possibly from internal AI responding to environmental data. Autonomous spacecraft exist. We've built them. Mars rovers, deep space probes. Now imagine a craft launched from another star system, tens of thousands of years ago, pre-programmed to adjust trajectory based on nearby solar systems, light, heat, gravity. Not intelligent, just programmed, just waiting. And now, it found us. In 1960, physicist Ronald Bracewell proposed the idea of autonomous interstellar probes, not piloted by aliens, but designed to scan, analyse and report back. A Bracewell probe he theorised would remain quiet until it detected intelligence, then activate. Sound familiar? Dr. Avi Loeb's recent comments suggest he's leaning in that direction. In an interview with the Harvard Gazette, he said, 3I Atlas is showing behaviour associate with purposeful trajectory, correction. If it's a natural object, it's the most coordinated one ever seen. If it's not, he didn't finish the sentence. But we know what comes next. Because think about it. It travelled through space. Possibly for eons it entered our solar system along the ecliptic. Not randomly it accelerated, then stabilised. It's approaching Earth in perfect observational range. And now? It's silent, waiting. This isn't Oumuamua, fast and gone. 3I Atlas is lingering, staring, maybe even scanning. So the question becomes, are we the watchers or the watched? As December 19th draws closer, the world's amateur astronomy networks are preparing like never before. Across Europe, North America, Asia and the Pacific. Telescopes are being cleaned, sensors recalibrated, and live streams queued up. The International Astronomical Union's public engagement branch has launched a Watch the Visitor campaign, encouraging people worldwide to participate in real-time tracking. From backyards in suburban Ohio to university observatories in Delhi, telescopes will lock in on the object starting December 18th. Meanwhile, the Virtual Telescope Project will begin a 72-hour live stream of 3I Atlas on December 17th, using both visible and infrared feeds. But the real prize will come on December 19th between 03:10 and 04:30 UTC, when the object makes its closest approach, potentially within 30 million kilometres of Earth. Close enough for radar imaging, close enough for LiDAR, close enough for something to happen. Maybe it breaks apart, maybe it flashes, maybe it launches something smaller, or maybe it just keeps flying, silent, smooth, watching. And if that's the case, it may not have come to visit, it may have come to report back. To who, we don't know. But soon, we might. As 3i Atlas races toward its closest approach, speculation intensifies. Observatories are preparing, algorithms are primed, and the public watches with anticipation. But what exactly are scientists looking for? Let's break it down into the 4 main scenarios, each with drastically different implications. 1. A natural comet. This is the simplest and least exciting explanation. A dense, volatile-rich comet with nickel-heavy composition and unusual outgassing behaviour. If it fragments or suddenly begins shedding debris on December 19th, that would support this. But remember, it has shown no tail, high reflectivity, precise jet behaviour, and non-random acceleration. This would mean our models of comet behaviour are incomplete, but nothing extraterrestrial. 2. A metallic asteroid. This scenario interprets 3i Atlas as a dense interstellar asteroid, made of nickel iron, possibly from a collapsed star system. Its acceleration might then be explained by mass shedding via internal fissures. Problem is, again, no debris trail. And high spectral symmetry. Metallic asteroids don't glow blue. 3. MICE. Technological probe. Here's where things get controversial. This theory, supported by Dr. Avi Loeb and several fringe astrophysics groups, proposes that 3i Atlas is a Bracewell-class artifact. A probe designed not to communicate, but to observe, adapt, and relay. It wouldn't need AI as we understand it. It would follow programs. If Earth-based radio emissions reached it decades ago, it may have simply steered to investigate or report back. 4. A cluster of objects. Recent analysis of faint diffraction shadows around 3i Atlas suggest it may not be one object, but several, orbiting a central mass. This multiple body structure model could explain its unusual brightness spikes and light curves. It also raises the most questions, because if this is a controlled swarm, that implies engineering, advanced, intentional, and very, very old. So which will it be? The answer could arrive any hour now. As we record this, it's November 12, 2025. 3i Atlas is flying silently. No radio emissions, no thermal bloom, no high-frequency bursts. Passive, watchful, waiting. And still it pulses blue. The Galileo project in Las Vegas has detected no radar returns, but has registered a faint magnetic anomaly in coordination with ground magnetometers in Australia and Peru. Too weak to confirm, but timed precisely with a jet burst observed on November 10th. Coincidence? Or a systems check? SETI's Allen Telescope Array has also turned its gaze toward the object. No response. No pings. No signals. But that may not be how this thing talks. It might not be talking to us at all. It might be listening. It might be learning. As mainstream science debates propulsion and mineralogy, fringe circles are exploding with theories. In forums, podcasts, and deep space subreddits, the theories range from curious to cosmic. A remnant from a Dyson swarm, a weapon from a dead civilization, a monitoring node from a galactic network, a seed ship awaiting planetary alignment, a dormant craft waiting for a signal. One of the more viral theories is the silent gatekeeper hypothesis. It proposes that 3i Atlas is not the first, but the last, the final checkpoint in a long line of silent watchers. Not scouts, not invaders, but archivists, travelling for millennia, gathering data, storing everything, silently, and passing it on. And maybe Earth is just one stop. Others suggest something more dramatic, that on December 19th, when the object makes its closest pass, it may activate, emit a signal, or even release something. A smaller probe, a message, a warning, but as of now, nothing. Only silence. And light. In just over 5 weeks, 3i Atlas will make its closest approach to Earth. December 19th, 2025, that's the moment. Observatories will be watching. Satellites will be scanning. Spectrometers will be tuned. We'll know within minutes whether the object maintains speed, fragments, or does something none of us expect. 39:45, will we see a structure? Will it glow again? Will it change direction? Will it slow? Or will it disappear, vanishing into the dark like so many before? There are no guarantees, no script, no guidebook. Only observation. Only wonder. Only the sky. The strangest thing about 3i Atlas isn't what it does. It's what it makes us ask. What if we are not the first? What if we are not alone? What if this isn't exploration? But evaluation. Because maybe the universe is filled with watchers. Maybe not intelligent in our sense, but ancient, purposeful, quiet. And maybe, just maybe, they've been here before, and now they've come back to see what we've become. So as we look toward December 19th, as scientists, as storytellers, as people, we wait not for proof, but for possibility. Because even if this turns out to be ice and metal, the fact that we're even asking these questions, that's what makes us human. If you want to follow this story as it unfolds in real time, subscribe now. Turn on notifications so you don't miss the December 19th update. I'll be releasing a full analysis the moment 3i Atlas makes its closest pass. With any new imagery, signals, or anomalies caught by global observatories, leave a comment below. What do you think we'll discover? Will it pass by silently? Or will it change everything? I read every comment, and I want to know what you think, because as we look into the stars, sometimes the stars look back.